It was about a year ago when I was on this stage last time talking about the company I founded, but today I figured we should instead think more about innovation. And like Matt was talking about, why it is that there's this strange duality between constraints, which are really about limiting how things work, and freedom and creativity. And like I said, I'm the founder of this company. It's called Encore. We're an early stage startup, and what we do is we're building this thing called a backend development engine. And it's all built specifically for Go. We only write it with Go, and it's about making backend development better and simpler. And we think that can really help, unleash creativity and innovation. Since we're such a small team, I think literally our whole company is in this room right now. So if you find someone with this like weird, scary face, like go up and talk to them. And really what we're trying to do is create the world's best developer experience. And in backend development, there's so much complexity and repetition and boilerplate that we're really trying to get away from. And the end goal is that we as developers can really just focus on building our products. Enough about that. Let's, instead of talking about Encore and the product, let's talk about the underlying philosophy behind it. So what is innovation, really? If you look it up in a dictionary, this is maybe now more helpful. And every time I look something up, it just recursive, right? It's like, oh, it's the process of innovating. Like, thank you, that's very helpful. So let's do a quick game instead. And I want you to think of 7 different words that all end in the letter Y. And you have about 5 seconds. Good. Anyone get 7 words? All right. So if we make this a bit more difficult, that you're not only allowed to choose any word whatsoever, but it has to be a day of the week. So, Monday or Tuesday. Can anyone name 7 different words? No? Okay. So what's really interesting about constraints is it really helps focus the mind. And instead of just having this blank slate where your mind just goes blank because there's too many options. Like, what even is a word? Constraints help you focus on like this is the right area to be exploring. And Picasso famously introduced a lot of self-imposed constraints on his drawings. So this is an example of when he was trying to write or draw a dog using only a single line. And he felt that doing so, it really found the essence of the thing that he was trying to depict. So if we look more at software development and the innovation that's happening there, which is maybe closer to our hearts, like what's the trend and what's the rate of innovation in different areas of software development? Starting out with cloud providers. The cloud really came to be about 15 years ago, and it sparked incredible innovations in how we're deploying software and how we're running software in production. In recent years, maybe it's not so innovative because most of these foundational innovations have already happened. And so what's really happened is there's been this shift towards SaaS software. So when you're building your application, you're really using often like 10, 20, 30 different SaaS tools that each tries to find a small part of the problem and help you with it. So there's been this shift towards innovating in that sense. And looking more into how we're actually programming. Front-end as a discipline is, incredibly innovative. Many people feel like you get out from front-end development for a week and suddenly you come back after a vacation and it doesn't look anything like you remembered. And there's some truth to that, and it's especially stark if you compare it with backend development, where it feels like nothing is happening for the past 20 years. We're still just using the same tools, and maybe the programming languages have changed. But in the end, how we're writing software isn't that different. So why is there such a big difference between backend and front-end development? And what I think is happening is, when it comes to backend development, there are so many different languages in use. There's no majority language that everyone is using. So obviously these are not relative sizes. That's not really the point. It's really just to illustrate that there are lots of different languages. In the contrast, if you look at front end, it's very simple. There's really just one language. And for web, it's JavaScript or TypeScript, which is really the same thing. But interestingly, if you look at other front-end platforms, it's really the same story. On Android, there was Java for a really long time. These days, there's Kotlin, but it's really the same ecosystem. And on iOS, it was exactly the same thing. So all of these platforms are incredibly constrained, and it's really to the point where there's a standard that you really can only use a single language. And this is really the breeding ground for innovation, because you can suddenly make a lot of assumptions about how things are working. On the backend side of things, if you look at the development process, it's all, very little innovation in all of these things. And then as you get closer and closer to how we're deploying things in production, you start to get more and more innovation and things shifting. Kubernetes is very recent. You have a whole suite of observability tools and CI and CD pipelines and that sort of thing. And you can really draw a line between these. And on the left, you have everything that is language specific. And on the right, you have things which are language agnostic. As soon as you're running things in production, suddenly you don't really care about the language, because Docker. Docker came in as this universal abstraction that really just ate up everything that was programming language specific. And in doing so, it created this fantastic abstraction for how you run things in the cloud. And so it really squeezed out all this innovation from happening in the language and how we're writing code to instead happening on the server side. So if you look at how are we improving how we write software, it's not really about changing how we code, but really it's here's an API that you can use in your program, or here's an SDK that you can use. And that's sort of the peak of innovation. And that's because when you need to support 10 different programming languages, you can't really afford to spend a lot of time on any given one of them. On the front-end side of things, there is only one language, so it makes sense to spend a lot of time innovating within that language. So it makes sense to talk more about abstractions and constraints. And I think, what is an abstraction, really? What does abstract mean? As a programmer, I think a lot of people have a positive connotation to abstractions. If you ask a random person on the street, it's almost a bad thing. That's very abstract. It's not really a positive thing. It just means I have no idea what you're talking about. So abstract means devoid of detail. It means theoretical as opposed to something practical. It's something that exists in thought only. It's not physical or concrete. And here's another drawing from Picasso where he drew a series of bulls. On the left, you have a very realistic set of drawings with a lot of detail. And increasingly to the right, he removed more and more detail, and he made them more and more abstract. So abstraction is fundamentally about saying less. It's about having less information. And how does this translate to programming? Interestingly, Picasso started from saying a lot on the left and then removing detail, whereas when it comes to programming, we generally start on the other side. We start by saying nothing at all. So if you recall Rob Pike, he said that the empty interface says nothing. And what he means is, there's any type whatsoever implements the empty interface. And that means that there are no constraints whatsoever on what that type could be. So you have no information. But if we start to add constraints, we start to add methods to this, then suddenly we start to learn more about what this thing is. So if you have an interface with a single method like this, then suddenly it could be not anything, but it could be a couple of different things. It could be an in-memory map, it could be a cache, it could be a relational database. It's easy to implement this interface backed by a relational database. It could even be a database in the form of a JSON file on disk. It doesn't matter. It could be a CDN. It could be a DNS lookup. It could be a big table cluster or a file system implemented over DNS. It's very abstract, but it's at least saying something. When it comes to adding more methods, suddenly, it can't be all of these things. It can't really be a CDN anymore because a CDN is really read-only. So when you have a set method, you need to remove these things that are really about reads and writes. It can't really be a DNS lookup anymore. If we add another method, which is about give me the closest node to where I'm running, it becomes clear that this is no longer, an in-memory map, because the concept of a node doesn't really make sense. Same thing with a JSON file. This is clearly it's about some distributed storage concept. It can't be DNS either because it's not really a concept of nodes. It's just a tree of recursive resolvers. And finally, if we add a new column family that returns a pointer to a big table column family, hopefully it becomes clear that this is not a cache, it's not a relational database, it's a big table client. And so this is what Rob Pike was saying when he said that the bigger the interface, the weaker the abstraction. When you add a lot of methods to something, it's not an abstraction anymore, it's very specific and concrete. But I think what's interesting is it kind of frames this as a bad thing. If we create a big interface, we're failing, like we're doing a bad job, we're not abstracting enough. And I think in many ways, as software engineers, we're infatuated with abstraction. Why? Well, I don't know. I can make some stuff up. So when you're in school and you're studying computer science, there's a very heavy focus on abstraction. You learn about fundamental concepts like a file system. Everything is a file. You learn about TCP and how that just magically makes everything reliable. If you look at Java, which influenced a lot of object-oriented programming, in Java, you are forced to define all the interfaces up front. You have to specify, this type implements these interfaces. You can't define an interface later on. And so what happens is you really are forced to abstract from day one. And it really creates a culture of over-abstraction and constantly thinking about, how can we make this more abstract? And maybe it's also about feeling smart. You know, if you come up with a really elegant abstraction, and it really, you know, it's beautiful, you feel really smart. You know, nothing can bring you down. You really feel like, you know, your brain is flying. There have been lots of times where I am trying to solve some really specific problem, and you know, I need to upload some files to a you know, cloud storage or something, and I end up 15 minutes later, I'm sitting there, and I catch myself not doing that thing, but really designing, like, I need to build a general purpose stream processing system that can solve everything and world hunger while we're at it, right? It's really about this is the allure of abstraction. And coming back to Picasso, this is the most abstract picture, right? And you can really feel how proud he was of this one. You know, like when he was doing this, he was like, "Yes, I nailed it. You know, I'm a genius." But I think we need to remember that abstraction is just a tool. It's amoral. It's neither good nor bad. And we really should be asking ourselves, is this the right tool for what I'm trying to do? And there are a lot of talks about the benefits of abstraction. But I think what we really should be doing is talking about the other side of the coin. Like, what are the benefits of not abstracting, of being concrete? So when you abstract, you open up for interoperability. And that's a great thing. You know, I/O reader, I/O writer, it has created this whole ecosystem of abstractions and interoperable implementations. But it's also limiting. You know, when you define an interface, what happens is you can't really change it afterwards. You know, if the standard library changed the I/O reader implementation interface, the whole language would just explode. Like, no program in the world would compile anymore. But it's also about when you force something to be abstract, you can say very little about that thing. And so if we think back to front ends versus back ends, on the front end side of things, everything is very specific. There's just one programming language, and you can rely on that. On the back end side of things, it's abstract because you have to deal with lots of different programming languages. So let's explore the benefits of constraints. So as we're adding constraints, you know, everything goes from saying nothing at all to being abstract and eventually being concrete. We could actually take this a step further, and we could even say that if we add even more constraints, it actually becomes a standard. And this is what happens, you know, when you're a compiler. It's really, you know, a compiler is really one big constraint on how you're expressing programs. But it's different because it's actually, you don't have a choice. It's an enforced standard. So what that means is when you're writing Go, you don't have a choice but to follow what the compiler is saying. And what happens then is it creates this standard where you can really make assumptions about how something works. And this enables new experiences. And I think this is the most interesting thing about constraints and about standards is once you can rely on something being true, then you can start to build entirely new experiences around that. So a couple of examples from what we're doing at Encore. Interesting. Very abstract. Well, this is going great. It's actually showing up on my screen, which is even more infuriating. Let's skip over this and see if we. Wonderful. All right, let's try this. let's hide some stuff and let's do this. Haha. All right. So when it comes to what Encore is doing is we're really enforcing standards on how you're doing a bunch of things related to backend development. So there's only a single way of defining APIs. There's only a single way of defining cron jobs. There's a single way of defining pub subtopics and subscriptions, and all of these, cloud native concepts. And what happens when you standardize on this, then suddenly you can start to build an understanding of a system. So when you're writing a backend with Encore, you can do things like generate architecture diagrams or provision infrastructure automatically. And this is something that's simply not possible without standardization. To give an example from Go, in Go 1.10, they introduced test caching, which means that the first time you run Go test, it runs your tests. But if nothing changes, when you run it again, it doesn't run your tests. It just says it's cached. They already passed, nothing has changed. But how does it know that nothing has changed? It needs to understand not just that the Go code hasn't changed, but what is the test even doing? If it's reading files on disk, how can we be sure that those haven't changed? And so what they did was, inside the standard library, they added a bunch of lines like this, where every time you open a file, there's this internal package in the standard library called test log, which is recording that this file was opened. So when the tests are being run, Go can actually track which files are being opened and which files are being read, which environment variables are being read. And this is actually used in order to determine if something has changed. This would be completely impossible without standardization. If there were, a bunch of libraries out there that enabled you to read files without going through the standard library, then suddenly this would be completely impossible. And the user experience of writing and running tests would be completely different. And I think the most interesting things of all is, we've looked at a bunch of different examples for how innovation works, what the benefits of constraints are, and the sort of innovation and creativity that enables. And it's not just about programming, it's in culture, it's in how we think about words or problem solving. And I think it's interesting to ask yourselves, Go started out being this incredibly simple language. And I think a lot of people came into it appreciating its simplicity. And what happened, or what has been happening over the last couple of years is, and maybe especially with Go 1.18 and generics, is the language is becoming more complex. And I think when it comes to abstractions, Go started out being very limiting in the sort of abstractions you can create. And it created this sort of culture where you don't have to really think that much about how you're going to structure your program, because there was usually just one straightforward way of doing it. And that was one of the things that made me come into Go, was it really just got out of your way and enabled you to write code fairly directly. And today, Go has a lot more tools for abstraction. You can build much more elaborate abstractions for data structures and programs with generics and other language features. So should we be concerned about this? If the things that made Go so successful was its simplicity and the fact that we didn't have to invent so many abstractions and we could just focus on getting our job done, what does that mean now that the language is slowly becoming more complex? And I think there were a lot of language decisions that really created this sort of culture. You know, a programming language is much more than the feature set. It's almost more about the culture of how are you using it. What is the sort of conventions? So we talked about how Java forces you to create all of these interfaces up front. In Go, you don't have to create interfaces up front. You can focus on solving your problem, and if you need an abstraction later, you can define it later. Or someone else can create an interface because they need it. And I think this sort of decisions has really changed and fundamentally altered Go's culture around programming. So even though the language is slowly becoming more complex, I think it's really important that we keep to the culture of Go, which is about simplicity. It's about being direct and not overly abstracting things. And when you're writing your next Go program, maybe think a bit more carefully about, do we really need an abstraction here? Or should we just be more specific and more concrete, because it will enable us to create better experiences around that, because it enables us to create better assumptions and being able to rely on those assumptions. So that's all for me. I'll catch you in the cloud. And thank you very much.